This is the last part of a comprehensive guide to undervolt your NVIDIA RTX 3000 series graphics card with EVGA Precision. As we have previously seen with OCCT, after setting your max VF point, the frequency won't lock to your desired one, but sometimes will shift up and down one step. This shifting behavior is governed by your graphics card temperature and, I believe, other variables as well. Let's take all my 4 undervolting profiles as examples. With 1935 MHz at 900 mV, I've noticed that below 45 degrees Celsius, the frequency is indeed 1935. Between 45 and 50 degrees, it goes down to 1920. Between 50 and 55 degrees, it goes up to 1950. Between 55 and 60, it goes back to 1935. Between 60 and 65 degrees, it goes up to 1950. And above 65 degrees, it goes back to the one set. Same behavior with 1905 MHz at 875 mV. Below 45 degrees, set frequency. Between 45 and 50 degrees, one step down. Between 50 and 55 degrees, one step up. Between 55 and 60 degrees, set frequency. Between 60 and 65 degrees, one step up. And above 65 degrees, set frequency. 1860 MHz at 850 mV and 1800 MHz at 825 mV both behave differently. Below 45 degrees, set frequency. Between 45 and 50 degrees, one step down. Above 50 degrees, one step up, and the frequency remains there. These cutoff temperatures are purely indicative, as they can vary erratically over time and between runs. But in the end, this doesn't matter much. What matters is that your set frequency sometimes increases by one step, and sometimes it even continues to stay there. Watch this in real time. Albeit 15 MHz more shouldn't be a big deal, as I often said, stability is always crucial. Therefore, my recommendation is to decrease every VF point by one frequency step, starting from 800 mV. In this way, when your graphics card overshoots, it will do so at the correct frequency. One last quirky thing I noticed while studying this behavior. All frequency shifts are triggered by fake power and thermal limit flags. To show you in practice what I mean, I ran Superposition 8K with hardware info in the background. Its polling rate must be set to 100 milliseconds, since it's the only reliable way to always capture flags that last a few milliseconds. See? Power flag at 5555, thermal flag at 5555, frequency shift at 5555. I've labeled these flags as fake because I'm way below my real power and thermal limits. They are 240 watts and 83 degrees Celsius, respectively. Now you know why hardware info with its stock polling rate of 2 seconds every so often shows power limit yes and thermal limit yes, even if both power and temperature are fine. And so, my guide to undervolt your NVIDIA RTX 3000 series graphics card with EVGA Precision ends. I hope you enjoyed it. My next video will be about fan curve control, again in EVGA Precision. Farewell for now.